Welcome to Easy Legal Learning Simplified. My name is Eric. I'll be taking you through this topic area, and for this lesson, we're going to cover area of a sector. So we want to see what is this we are calling a sector, and how do we find its area? How do you find the area of a sector? So we have a few questions here that will help us to illustrate how we can find the area of a sector. How do you find the area of a sector? So these questions will basically help us with the illustrations on how to find the area of a sector. And of course, at the end of this lesson, we'll be able to give you some assignment just to help you with practicing on calculations involving area of a sector. So a sector is this region. Maybe if you call this A, and maybe this is B. So this is A, and this is B. So the region bounded by the lines OA, OB, and the curve AB, this region here is what we call a sector. Actually, the definition, a sector is described as a region that is bounded by two radii and an arc of a circle. So you see we have the arc AB, and we have the radii here, bounded by the radii and the arc. So there are two sectors here. We have the sector OA, and B. You see the sector OA and B. That is smaller compared to, we say it is less than half of the entire circle. And then we also have, maybe I can call this one X, and the other one I can call it Y. So we have OAB or OAXB, and we have OA, so we have OAYB as minor, this one here, because it's less than half, so we call it minor sector. And then we have OAXB. This one is now more than half of the circle. So we call it major. So we have two of them, minor sector and major sector. So the minor sector is the one that is less than half, the region that is less than half the entire circle. Then the region that is more, this region that is more than half the entire circle, we call it major. So the area of a sector like OAYB can be obtained by using this formula here, theta over 360 times, this is times pi r squared. So r there is the radius. So r is the radius of the circle. For example, r in this case could be OB. So this theta here is used to represent the angle that is subtended by the arc at the center. So this angle can be acute, obtuse, or reflex. So it can be this angle here, or it can be this other one here. So this other one here is reflex. The other one is, so it can be this one in red, or it can be the one in blue. So the one in red can be this one here. It can be obtuse or acute. But if you look at the other one in blue, this other one here, it's absolutely reflex. So if you are finding the area of the major sector, then you'll have to use this angle here. Now in that case, you have to use this angle here. That is finding the area of the major sector. So that even if this other one was given as, let's say, 60 degrees, then you have to subtract that 60 degrees from 360 to give us 300 degrees. See. So that use 300 degrees. So 300 over 360 times pi r squared. Basically, a sector is just part of the entire circle. So this is area of the entire circle. So there is a fraction of the circle represented by the area of the sector. So how we obtain that fraction is basically the angle subtended by the arc, or angle subtended at the center, divided by 360 degrees. So we have an example here, or we have examples, and the first one is find the area of a sector of a circle of radius 3 centimeters if the angle subtended at the center of the circle is 140 degrees. So I'll just use the formula. I will just use the formula. So let me subdivide this space into 3 so that I have more working space. So the area is given by, so theta over 360 times pi r squared. Remember, this pi r squared here is just the area of the circle, the complete circle, but then we have a fraction of it represented by the angle subtended by the arc of that sector, or simply the angle subtended at the center of the circle divided by 360. So we have something like this. So the angle subtended here is 140 degrees. This is obtuse. So this is 140 degrees. And we are trying to find that area, So the area we are trying to find is this one here. So the theta here is represented by this angle subtended at the center. So let me substitute now. So I have theta, which is 140. You divide by 360, and then you multiply by 22 over 7 times the radius, which is 3. So that is 3 by 3. So we will try and simplify. So 3 here, 1, 3 here, 1, 2, 0. Again, 3 here, 1, 3 here, 40. So this 0 cancels the other 0. And so you have 2 here, 1. 2 goes into 4 2 times, and 2 goes into 11. 22, 11 times. Again, 2 here once, and 2 goes into 14, 7 times. And so what I have is 7 by 11. So my area is going to be 7 times 11. And then you divide by 7. So still this 7 goes here 1, 7 goes there 1. So the area is 11 square centimeters. Remember, area is measured in square units. So that is basically how you go about it. It's very simple. It's not really hard. We have another example here. So the area of sector of a circle is 38.5 square centimeters. Find the radius of the circle if the angle subtended at the center of the circle is 90 degrees. So again, we just write the formula. So let me try and again subdivide my space into 3. So I have this, and then I have this. So area is given by theta, that is the angle subtended at the center, over 360 times pi r squared. So area is 38. So we substitute in the order in which the formula is written. So we start with A, which is 38.5. So 38.5. So what is the angle subtended at the center? 90 degrees. We divide by 360. then you multiply by 22 over 7, and then you multiply by what? By the radius. So the radius is what we are trying to find, so that is r squared. So now, to find this r squared, I'll multiply the other side by the reciprocal of all this that is here. So I'll multiply the left-hand side of the equation by the reciprocal of this. So it means my r squared is going to be 38.5. You multiply by 360, you multiply by 7, and you divide by 90 times 22. So you see I've multiplied 8 by the reciprocal of 90 over 360, and then the reciprocal of 22 over 7. So let's try and simplify this again, just like we did it in the other case, or in the previous example. So 90 here once, 90 goes there 4 times. See. So again, we have so I will now multiply this by 7, and then I divide by 22. So let me do 38 or 385 here. So you have 385, you multiply by 7. So 7 by 5 is 35, 5 carry 3, 7 by 8 is 56, plus 3 is 59, so 9 carry 5. So 9 carry 5. So 7 by 3 is 21, plus 5 is 26. Then we had one decimal place because of 38.5, so we have 269.5. So our answer is going to be 269.5, and then you are dividing by 22. So let me try do that division. So 269.5, and then you divide by 22. So 22 goes into 26 once. 1 times 22 is 22. You subtract, this is 4. You drop 9 here. 22 goes into 49 2 times because of 44. So 2 by 22 is 44. You subtract, this is 5. You drop 5 here. So 22 goes into 55. Again, that is 2 times, and 2 by 22 is. So after this, you can add a number of zeros. So 22 goes into 55 2 times, and 2 by 22 is 44. So this is 1, and again 1. Then you drop the next 0. So 22 goes into 110 how many times? So 22 goes into 110 5 times, and 5 times 22 is 110. And then the decimal point will jump up there. So this is going to be 12.25. So now we want to find the square root of, because now we have r squared is equals to 12.25. What about r? So r is going to be the square root of 12.25. You know, if you have r squared here, to get what r is, you simply find the square root of, you know. So you can use a table to help you find the square root of 12.25, and that is going to be 3.5 centimeters. So it's just as simple as that. Now there is another one here whereby we have the area of a circle radius 63 centimeters is 4158 square centimeters. Calculate the angle subtended at the center of the circle. So again, I will just write down the formula. So A is equals to what? Theta over 360 times pi r squared. So area is given as 4158. So this is equals to theta, and theta is what you are finding over 360. You multiply by 22 over 7, which is pi, and you multiply by r squared. So our r squared is going to be 63 by 63. That is our radius. So again, over 1 over 1. So to find the value of theta, just like I did in the previous case, I'll multiply the left-hand side, which is 4158, by the reciprocal of, so I'll multiply by the reciprocal of all this. So let's see how that is going to work. So this is going to be 4158. You multiply by 360, you multiply by 7, and then you divide by 22 times 63 times 63. So now what remains is now doing this simplification. How do you simplify that now? So let's see. So 11 goes here twice. 11 goes into 41 three times because of 33. So what is the remainder? So the remainder is 8. 85, that is 7 because of 77. And of course the remainder is 8, and 88, that is 8. Now 7 goes here once, and 7 goes here 9 times. 9 goes here 7 times, and 9 goes there how many times? 4, 40 times. So you can still subdivide further. So 2 goes here 1, 2 goes into 40, 20 times. Now 9 goes here once, 9 goes into 380, 378. So let me use 37. So 9 goes into 37 4 times because of 36. Remainder is 1, and that one taken to 18 to 8 will be 18, and 9 goes into 18 2 times. And finally I have 7. So 7 goes here once, and 7 goes into 42 how many times? 6 times. So we have this remaining, and then we have 20. So it means the angle that you are looking for should be 6 times 20, and multiplying 6 by 20 will be just a matter of multiplying 6 by 2, which is 12. Then you add the 0 here. So this is an angle, so it's measured in degrees, so 120 degrees. So that is all. We have some questions here to help you with practicing, and just to help you gauge on your understanding of the concept as we have discussed through the lesson. You can always attempt and send feedback on the comment section. We'll be looking at them and giving feedback in the details. Otherwise, that is all for now. Till next time, goodbye.